Welcome everyone. This is our launch webinar today for our brand new feature of Amazon OpenSearch Ingestion. We've lined up a super smarty panel for you today, including Arjun, who is the senior product manager for this feature, and Muthu, who's incognito. I dare you to find him anywhere. He's invisible. He's a silent assassin of OpenSearch. So with that, let's get started. Let's go to the agenda of what we're going to show you today. Today, we're going to talk a little bit about what is OpenSearch, how that relates to OpenSearch Data Prepper, as well as then dive into the features and the benefits of OpenSearch Ingestion, which, as I mentioned, just launched last week. We're super excited about it. Muthu is going to do a live demo for you, so super exciting. That'll be maybe 10 minutes long, and he'll show you some of the cool new features there, including blueprints. And then we'll talk a little bit about what's coming next. Throughout this session, we will be having a live poll, so keep your fingers to your keyboard while I'm asking you a few questions, and we'll show those live poll results as we go. So with that, let's get started. The first question we get is just, what is OpenSearch? OpenSearch is an open source, community-driven engine for search and analytics. It has a few major components. Number one, the engine, which is OpenSearch. Number two, a visualization and UX interface, that's OpenSearch dashboards. And the third component is Data Prepper. Data Prepper helps you with that ingest pipeline. So those three big components of OpenSearch. It was first launched in Q3 2021, and since then has grown in popularity. You can see the stats on the right-hand side of the screen, including the number of partners that are participating in this, the amount of growth of the pull requests that have been merged in, as well as the one we're really proud of there, the top 4 search engine in DB engines. So we're super excited about that. But all of this to say that there's been a lot of attention on OpenSearch. You can see 150 million downloads since it launched. That's a huge number. Lots of people are using it. And we hope that in the session today, you'll start to see some of the reasons why. So with that, let me kick it over to Arjun to talk about what exactly is OpenSearch Ingestion.
Hey, thanks, Aina. So before we actually get into what OpenSearch ingestion is, I think it's important to sort of take a step back and understand what were the existing challenges with ingesting data into OpenSearch. So OpenSearch does a damn good job of, like, once the data is in there, it will give you the exact sort of results you want. It will do semantic searching for you. It's super intelligent, intuitive. It has a rich API set. So you can do everything that you can expect from like a search engine like OpenSearch. The problem though is that for those search results to work and for you to get the rich data that OpenSearch gives you, you need to get the data into OpenSearch first. The problem, so that's the crux of the problem. So, and that stems from the fact that data coming to OpenSearch can come from like a wide variety of sources. And not only text data, which traditionally has been the bread and butter for OpenSearch, but of late, we've also seen a lot of observability data coming to OpenSearch. And this can be in the forms of logs, traces, metrics, and can be generated by like a wide variety of sources. So this can be from very basic syslogs, web server logs. Just within AWS, there are so many services that generate logs, VPC flow logs, there are WAF logs, and multiple services that generate a ton of data in the forms of logs. And OpenSearch is the perfect destination for all of it because it has the right set of tooling, the right set of dashboards for you to then draw insights out of it and take actions. The problem is given the wide variety of data sources the data is coming in from and the formats, to normalize all that and get it into one standard format is super difficult. The other problem is the rate at which the data comes. Some data is just perfect for batch, wherein you have data that probably comes in twice in a day. And so it's perfect for you to batch it up, run your cron jobs probably at that particular time and then send it in. Certain other kinds of data are perfect for streaming. It needs to come in throughout the day, 24/7. So you need to have a pipeline that's just continuously looking for data coming in and then writing to OpenSearch. And finally, the other problem that most of our customers told us is the fact that they need to transform the data on the fly, not once it's indexed. There are a lot of use cases where they want exact like sub-second replication. They want the data to be transformed on the fly. You need to run ETL on the data that's actually going through a pipeline. And we, at least before OpenSearch ingestion or data prepper, we did not have solutions for those.
Yeah, so let's take you to the first question. If you guys can answer this question, the screen will come up giving you some options, but we're really interested on, have you faced challenges ingesting data in OpenSearch at an enterprise scale? Have you tried this? Has it worked great? So while we're waiting for your answer, and we'll show the results for that poll when it's in. Um, Arjun, I think the other challenge that is kind of implied in the question, in the slide you just showed, was the cost of all of that data routing in. I mean, can you talk a little bit more about that, at the challenges of controlling cost with all that data?
Yeah. So yeah, again, as Aina said, right? I'll talk about data prep after this, but cost is a major factor, which is a lot of data that flows in is probably not of value to you. I mean, it's like finding a needle in a haystack, right? You have like tons and tons of data. Do you really want to take all that data into OpenSearch and then index it and then run queries on it? Or do you want to like sample the data, take a subset of it, and then still arrive at the final decision that you would have anyhow arrived at, but not index everything and then bear the cost consequences for it? So cost is again a major factor of it, which is a lot of this data is noisy in nature. So most of our customers have said, hey, I do not need to like every syslog or every system generated metric need not be indexed. Is there a way where I can just get a sample of it and then extrapolate it to arrive at the final decision? So that's again one of the challenges.
Perfect.
So
Perfect. So let
yeah,
me just, Dana, can we show the poll results then?
Unfortunately, we actually didn't get any responses in the poll
Okay.
question. We've got a
Okay.
quiet list of attendees today. So
Okay.
if you actually do have responses or answers you'd like to address in the question that we had posed, feel free to type that into the chat and we can monitor that as well.
Perfect. Thanks. Well, Arjun, kick it off then.
sure, thanks. So yeah, so I think, and given that we had all these challenges that I spoke in the last slide about ingestion, the first thing that we did was we had this open source product. So the open search team at AWS is open source first. So everything that comes out first is open source, and then if needed, we then have a managed service offering for it. So Data Prepper was a solution for the ingestion needs of OpenSearch. It was meant to, given that OpenSearch was forked from Elasticsearch, Data Prepper was meant to be a equivalent for Logstash. And Logstash, in the Elastic world, Logstash is what you do if you want to ingest data into Elasticsearch. Our solution is Data Prepper. And Data Prepper is meant to be like a server-side collector. It can filter, enrich, transform, aggregate data, and do any sort of ETL job that you want to do on the data while the data is in motion. Um, the notion of a data prepper, the data prepper basically consists of a data prepper pipeline. And for a valid pipeline, you at least need to have a source and a sink. A source is where your data is coming from, a sink is a destination where your data ends up. Optionally, you can also have processors, and processors define as to what sort of transformations you want to do on the data. So we have use cases where customers want to drop a certain field because it's probably personally identifiable information. They don't want it to be indexed. So you probably drop it. There are certain processors where you want to run some pattern matching. So you can have all these different kind of processors. We also have buffers, which is in case there's a lot of data flowing in, you can have some sort of buffering in memory or on disk where you don't overwhelm the pipeline. The buffer takes care of huge volume of data coming in, takes care of the back pressure, and ensures that your pipeline is working properly. We natively support a ton of sources, processes, and sinks. So all that work, all that good work happens on the open source side. The community has contributed. We shepherd the open source project on GitHub, and so if you go to the open source docs, you will see like all the sources, sinks, and processors that we support. Apart from that, there are also like a lot of advanced features. We have first class support for trace analytics. So for example, if you need to run a distributed trace analytics pipeline, we can do that along with the observability plugin on the OpenSearch side, along with Data Prepper trace analytics. You can get very granular insights about what sort of traces are there in a distributed system. We have things like conditional routing where you need to decide where to send the data on the basis of something in the data. We have DLQs, which is, for example, you don't want to write all the data to your sink. If the format is wrong, you can actually send it to a alternate destination. So all these features that you expect from like a first class data pipelining solution are already there in Data Prepper. And so we've had Data Prepper for quite some time. We've had it for 2+ years. It's been very popular in the open source community. People have been using it. And in the last 2 years, we've got a lot of feedback from customers saying that, hey, why don't you have a managed service offering for this? Whereas what customers have told us is that they don't want to endure the headache of like running data prepper on their own. All they want is an API endpoint. They want to write it to. It has all the features that data prepper offers, but takes away the burden of like running the pipeline, provisioning it, understanding how to scale it, scale down, depending on your ingestion needs. All those things customers want to be abstracted away. And that's what has given rise to OpenSearch ingestion. And so OpenSearch ingestion aims to be this data ingestion tier that sits in front of either your serverless collection or your managed service domains and can accept data from a wide variety of sources, everything that data prepper supports today and more. And it will accept, filter, transform, enrich data, everything that you expect data prepper to do, and OpenSearch ingestion can do, but it's just an API endpoint. It's completely serverless in nature, so you need not worry about, hey, what sort of should it be x86, should it be ARM processor, what is the size, what's the CPU, you need not worry about anything. All you need to do is to set an OCU limit. We call it OpenSearch compute unit. You can just set a min and max for it, and it will scale up and down within the ambit of those limits. And it'll ensure that you need not do anything else. You just need to define your business logic as to, hey, my data is coming from this source, and this is the transformation I want on the data, which you were anyhow doing on data prepper. So you can basically, if you already have on-prem data prepper, you can just get all your business logic, all your code to OpenSearch ingestion, and it will just work right out of the box. Also, it's powered by open source components. So the power of open source is that if you think things are not moving along, you can always contribute. You can, so for example, if you want a feature, we have our customers who have contributed to OpenSearch, and then that flows into the managed service. And as you can see, it supports both serverless collections. So we just had serverless that launched sometime in Jan this year. So you can write to both an OpenSearch service domain as well as a serverless collection. So these are the major features. So the one on the right side are basically data prepper features. So I'll not talk about them because we've already gone through that. You have all the filters, you have getting metrics from data. The interesting portion is the right side features, which is what you get with it being a managed service. So firstly, it's like completely pay as you go service, which is you just need to, you pay only for the data that the data you're transforming. You don't pay for the infrastructure per se. So it will automatically scale your pipeline to meet your ingestion needs. You can also so it's completely serverless in nature, which is not only, we can actually pause your pipeline. So for example, if you see data is coming, it's very bursty in nature, comes probably like only during business hours from 9 to 5. You can ensure that during off business hours, you can completely shut down your pipeline and you incur no cost for it. We also provide very popular blueprints, which is, for example, writing a YAML file for your business logic takes some time. And as a managed service, we provide this out of the box so that you can hit the ground running immediately for the most common use cases. Muthu will probably in his demo show that as well, so that you can see how it actually works. Also, given that it's a managed service, the security, the onus is on us, on the service team, wherein we ensure that all CVs, all bugs, it's patched. We keep your pipelines updated to the latest version. So all those operational headaches are completely abstracted away. Again, given that it's a AWS tier 1, tier 2 service, it's you are assured of the reliability, security, and scale. So it's completely cell-based. It's a multi-AZ architecture. So even if AZ goes down, there's a backup AZ. We have an end-to-end message acknowledgement, which none of which even Logstash doesn't have. So we ensure that once your data is in a OpenSearch ingestion pipeline, till the time it's written to a sink for a pull-based data source, we never lose the data, even if the underlying process crashes. It's also integrated with very battle-proven technologies like S3, and we have support for DLQs. Things like SIG v4, IAM, private link, anything that you expect with AWS service, it's all baked into the service. Also, blue-green deployments are like a paradigm that our users are very common with in terms of upgrades or moving their data with managed service. So even in like a data in an OpenSearch ingestion pipeline, you want to upgrade your pipeline or move your data from pipeline A to pipeline B, we use the blue-green deployments. We also tested it for very high scale and very high performance throughput. We had a beta that ran for roughly 3 months, and with customers who had like very demanding workloads. And I'm happy to say that we're able to meet all those workloads. So we can probably have a separate session we can talk about as to what sort of scale we can meet, but we've pushed it to the limits, and OpenSearch ingestion has been able to, in all our testing, has been able to accommodate all those limits. Primarily the benefits, as we've sort of been alluding to it from the beginning. The first thing is you reduce storage cost, right? Which is you need not index everything now in OpenSearch. A lot of this data is noisy. VPC flow logs, if you set up VPC flow logs, it generates like a ton of data. You don't need all that. So you can write business logic in your data pipeline which says that, hey, only if a condition is met, index the data. Rest, probably drop it. So you can like all the data that you're indexing and paying for it, you could reduce all those costs. And so your AWS bills for OpenSearch will dramatically come down. The other thing is that you can enforce data quality now because you're doing transformations on the data at the source now. You have different sources coming through a middleware pipeline, but at the middleware pipeline, you can apply the business logic which says that, hey, all these data sources coming from n number of different sources need to be then normalized to one format. So helps you with things like, for example, you've had a major network outage, rather than like going sifting through like 10 different data formats, JSON, CSV, Parquet, given that all your data is in one format now when it's indexed, all these resolution time for these incidents also come down dramatically. Finally, we've had customers, healthcare customers, financial customers who are very sensitive to like PII data not being exposed. So while the data is in motion, before it's indexed and before people have access to it, you can like protect all the data, remove information like gender, social security numbers, credit card data, so that once it's finally written to OpenSearch and it starts being searchable, all those fields are then sort of obfuscated. So you don't have to worry about it.
Perfect. So let's have one more question, you guys. I'm just going to give you a short bit of time to answer this one. What kind of data do you plan to ingest using OpenSearch Ingestion? And maybe while we're waiting for that question to come through, I think we're about ready for the demo. Yeah, Arjun?
Yeah. So I'll probably just go over one slide so that before Muthu starts his demo
Okay.
as to how does a data pipelining workflow work, right? So once you land to OpenSearch console, now you have another tab there which says pipeline. So the first thing you need to understand is that your data can come from a wide variety of sources. So setting up that initial permissioning is important. It's super flexible. We allow you to like ingest from sources in different accounts, from on-prem, from other places. So you need to set up the initial permissioning, which will take some time. But once you do it, it's then a very seamless process after that. So first you set up the initial permissions. The documentation is super detailed, granular, talks about what sort of IAM permissions you need to give, what sort of roles you need to create. The pipelines can assume those roles. Then you create a pipeline. A pipeline, again, creating on the console is super simple. A few clicks, you name the pipeline, you decide does the pipeline stay in a VPC, is it a public pipeline, all those things. Just for AWS infrastructure to know where to create your pipeline. Then this is the interesting part. This is a YAML file where you define your business logic. You define as to, hey, my data is coming from this source. I need to apply this transformation. If it's in CSV, I need to convert to Parquet. And then probably add conditional routing says 200 OKs can be sent to OpenSearch ingestion, 500 errors, drop, or vice versa. If you are like sort of hitting a roadblock with defining that YAML file, because again, YAML is like few lines of code. We also provide blueprints out of the box. So again, just drop down and they're blueprints for most of the common use cases. So for example, you need to ingest WAF logs. You just click the blueprint and the blueprint will auto-populate everything there with sensible defaults. And it also gives you the option to change stuff, but you can hit the ground running in like a couple of minutes with the blueprints. Once you have set that up, then you can start writing to OpenSearch ingestion. You can actually see the data flowing from your source to the sink. And finally, now given that you have basically whittled down the data from like tons and tons of data to only what you need, you can then use OpenSearch dashboards to quickly analyze what's happening, and getting insights out of data will be much faster than you having to sift through like tons and tons of data, because now you've sort of normalized it, reduced it, filtered it, and only looking at what is important for you. So having said that, I think it's time for demo. Nothing like actually seeing it in action. So what I spoke about, I think Muthu will like run you through what we have in the AWS console so you can actually see it in action.
Perfect. Thanks, Arjun. Over to you, Muthu. Do we need to switch the screen share?
Should be able to see a screen that says observability shop. Is that right?
Yeah.
Perfect. Yeah. So thanks everyone for joining today. As Arjun mentioned, you probably have heard about what is called this observability. It seems to be a buzzword everywhere. Every enterprise seeming to build an observability solution. And as Arjun mentioned, observability comprises of three main signals: logs, traces, and metrics. And logs, something that we all know and love, and we have been building solution around for a long time now. With observability in focus, two other metrics also comes into view, that is traces and metrics. Traces are a bit like logs because they give you the current state of your application and how they are interacting in a particular point in time. But one thing to keep in mind is that the traces are going to be order of magnitude or even a few times more the volume of the more the volume that you are used to with in receiving logs actually. So you can expect traces to be of very high volume, and all the strategies that Arjun mentioned with conditional routing, sampling, are gonna gain an increased prominence now with the traces ingestion. So I thought I will show you how easy it is to set up traces ingestion with OpenSearch Ingestion and visualize the trace signals in OpenSearch dashboard to gain insight quickly. For that, we built an e-commerce shop we call this observability shop. It's meant to resemble like Amazon, where you click something and buy it. In this case, I need to name these better, but this is an item I'm going to buy. Click next. I'm going to do one-click purchase like Amazon that you're used to. Click next, get the order status and so on, just to generate some traffic on this. Imagine the situation where your customers of these e-commerce applications are complaining, saying that, hey, my checkouts are taking a long time. Can you identify what is the cause of it? So today, hopefully in the live demo, we are going to zero in on what particular service that is taking a long time without doing much of a work, something that we call as mean time to knowledge or mean time to resolution, the time it takes for us to from the identification of problem to fix it. So one of the aim for OSI and the Amazon OpenSearch observability is to reduce this mean time to knowledge and mean time to remediation actually. So this is the e-commerce application. Let me show you how it actually is laid out. The e-commerce application is a microservice application running in different microservices in different containers and running on EKS. So it has like 6 or 7 built-in services called payment, order, inventory, database, authentication, and so on. Each of them communicate with each other in making your user experience better. So what they are running in EKS, and what they do is that they produce these signals, logs and traces, and these traces will then be returned to OpenTelemetry collector. In this case, I'm running an AWS distro for OpenTelemetry collector, which is an AWS supported solution and OpenSearch distribution. It is the same open source OpenTelemetry collector, but comes with AWS support. So it's like a win-win situation for both. And then the collector then writes the traces through the OpenSearch ingestion pipelines, and then they write the processed traces into Amazon OpenSearch service. Similarly, the application then writes the logs through OpenSearch ingestion through Fluent Bit actually, and the pipelines again write it to Amazon OpenSearch service. So this is the 100,000-foot view of what the architecture is like. Our aim today in the live demo is to see if you can quickly identify what service that probably is showing the signs of strain by looking at the UI in OpenSearch service. As Arjun mentioned, creating this pipeline, creating the OpenSearch ingestion pipeline is very critical to accept the traces and logs signal and write them into OpenSearch. Of course, we have metrics pipeline too, but I'm not showing this for the demo today. But creating the pipeline is pretty easy and straightforward. Let me see if you can move this one out. No, I cannot. Okay, I need to move the window down a little bit. There we go. So if you go to Amazon OpenSearch console, you will see a new section called pipelines, and we also made it to look like new. So if you click on the pipelines, you will see this console, and in the console, you can see what is called this create pipeline button. When you create this pipeline, you can name it, and as Arjun mentioned, you can set your OCU scale from minimum to maximum, and OpenSearch ingestion automatically scales it based on different factors whenever you send data to it. So it is serverless, managed, easy to scale. One of the things I want to draw your attention upon is called this configuration blueprints, because this helps you get started very easily, very quickly with a couple of buttons. In this example, I'm going to show you building this trace analytics pipeline. So for that, there are various pipelines as Arjun mentioned, but if you select the trace analytics pipeline, it is going to build a pipeline configuration automatically for you. And this looks textually like this, but what it represents is something like this. It creates 3 pipelines for you: entry pipeline, span pipeline, and service map pipeline. And OpenTelemetry Collector is going to write these signals into the entry pipeline, and then entry pipeline then conditionally bifurcates the data to a span pipeline and a service map pipeline too. The span pipeline then calculates metrics from the spans on ingestion for those pipelines. And the service map pipeline is going to create a nice looking visual service maps and write the data into OpenSearch. So this is how the built-in blueprint works, the pipeline works. And it's very easy. As Arjun mentioned, it's all populate. All you have to do is provide your credentials and the roles that you create and click on this next button. There are other options too, like for example, creating your CloudWatch logs to know the health of your pipeline. You can create in VPC or public access. We recommend VPCs. And there is a nice button to validate the syntax of your pipeline too. You can use that to check and run it anytime. And then go to the next step, and let me quickly do that too. When you create, there will be a button that says, okay, create every configurations are ready and create pipelines. Once you create the pipeline, I've already created this for you. I will show this to you in this observability pipeline over here, and it shows the entire configuration, my Amazon service, OpenSearch service domain configuration, the permissions required, and so on. So pipeline is up and running. The next step is then to produce some data to it. In this case, we already did. I did some clicking around over here, and that generated logs and traces and wrote it onto OSI. OSI then wrote it onto OpenSearch. Here is a dashboard, OpenSearch dashboard which shows you the data that is written in OpenSearch. And I'm going to go into the observability pipeline right now and trace analytics. And by default, you're going to analyze all the traces that come in the last 5 minutes. Okay, let us see. And you see that these are the different trace groups that we have. These are the collection of spans coming at a same pipeline toward a particular path. Those are trace groups. I know once you hear it, I never asked me a question before, and I answered a question 1 year later. So service maps is another that feature that shows a graphical view of the interacting services that shows you different metrics like latency, error, and throughput. In this case, I'm going to look for the service that has a highest error rate. In this case, I need to make some more clicking around here to generate some data that show that we can get those this one going, the service maps going, cancel the order. It is taking some time now. Come on, go for it. Next. Okay. And then what I'm going to do is I'm go there and refresh my dashboards here. Hopefully, just by looking at this error rate window, you can see that there is a particular service that is showing 100% error rate, and this is called client checkout. And then the error rate window, you can see one of them that is highlighted with the bright red, showing that is the highest error rate. In this case, this one is. Let me make the window smaller. It is the client payment service that is making the error. So that is how you go from getting your signals to insight into data very quickly. Hopefully it has been useful to you. We will share some links and we'll go from there. Arjun, back to you.
I don't think we have time for the what's next.
Oh, we don't? Okay, cool.
Yeah.
Yeah.
So some people know how they can contact us, but it sounds like those blueprints are super impressive to get people started really quickly. So love to see that. Arjun, over to you to wrap it up.
Yeah.
And we're going to skip the polling question too. There we go.
Yeah. So I think just as Muthu said, right, if you want to get started, get onto the console, create a pipeline. It's super simple. There are blueprints in there. The documentation is very detailed. It has 2 getting started tutorials, in fact. So one is for trace analytics, one is for creating a log pipeline, understand how that does, and multiple blogs that we published as part of the launch. So go over all that, and ton of resources on the AWS side. As always, it's also, we're open source first. So everything that's on the opensearch.org is right there. So the services, the roadmap is again on GitHub, developer guide, our partner network, again on social media, Twitter, LinkedIn, Facebook, Twitch, we're all there. It's open source project. The community is super active, vibrant. So get on there, tweet out your ideas, things that you want to see on the service, and we'll be actively scouring those things to see what people are commenting and try to incorporate as much as possible and try to get that in the service.
Perfect. So if you want to move to the contact slide, thank you everyone for joining us today. This session will be recorded. You'll be able to check back on it later. And also just thanks so much for participating. I hope you enjoyed the live demo, which all worked. We're going to let Muthu go and dash off to an open source conference. So thanks everyone today, and we look forward to hearing from you.